Okay, so in the last class, we were discussing ionic bonding. I told you the definition of ionic bonding, that was electrostatic force of attraction between the oppositely charged ions. And also we did some structures, we drew some structures in the last class, including we have drawn sodium chloride. We have drawn sodium chloride, in which I told you that sodium proton number is 11 and the proton number for chlorine is 17. The proton number for sodium is 11 and the proton number for chlorine is 17. Okay, so this is sodium and this is chlorine. And obviously we are going to draw the dot and cross diagram. Dot and cross diagram means that only you have to show outer electrons. Remember, dot and cross diagram means that you have to show only the outer electrons. Only outer electrons. You are not supposed to write inner electrons. Remember, you're not supposed to write inner electrons. Let's suppose, how can I convert the normal structure into the dot and cross structure? Let me tell you. As you know that this is the nucleus of sodium, and in the first shell it has 2 electrons. In the second shell of sodium it contains 8 electrons. In the third shell of sodium it contains 1 electron. Am I right?
Yeah.
Good. So this is having 1 electron in its outer shell. This is the full diagram. This is the full structure. We are supposed to draw only the dot and cross structure. And what I told you regarding the dot and cross diagram, you are supposed to only draw the outer electron. So I am removing inner shells. This is the dot and cross diagram for the sodium. Okay, and then let me draw chlorine first. Let me draw chlorine first, in which I have 7 electrons, because the proton number for chlorine is 17. 1, 2, 3, 4, 5, 6, 7. Okay, so obviously I am going to draw the dot and cross diagram. I'm not supposed to draw the inner shells. So these are the dot and cross diagrams for sodium and also the chlorine. Are you getting my point?
Yes, sir.
So sodium would be losing its electron to this chlorine. Obviously, after the removal of this electron, so then how many electrons would be there in the outer shell? You will say 8. And how many electrons would be there after gaining this electron? So you will say 8. How? If you can see this electron came from sodium. I have changed the color so that you can understand where this electron comes from. So after losing or gaining electron, their outer shell becomes stable. So it has a positive charge, it has a negative charge, because it has gained electron, it has lost its electron. And then after becoming oppositely charged ions, they would be attracting each other in such a way that they would be forming an ionic compound. In this way, the sodium chloride is formed. So sodium chloride is an ionic compound, and it can be formed by the reaction of sodium with chlorine. As you know that the sodium is a metal, and chlorine is non-metal. Okay, sodium is metal and chlorine is non-metal. So sodium would be losing electron, chlorine would be gaining electron. So when chlorine gains 1 electron from sodium, it would be having a complete outer shell, would be having -1 charge. And after the removal of 1 electron, sodium would be having +1 charge. Once the oppositely charged ions are formed, so they would be attracting each other. So that's why I can say that there would be an electrostatic force of attraction between oppositely charged ions. Are you getting my point?
Yeah.
In the same manner, in the same manner, in the same manner, we are supposed to draw the dot and cross diagram. We are supposed to draw the dot and cross diagram for magnesium oxide. You are supposed to only draw outer shells. You are supposed to only draw outer shells. I'm not telling you anything else. You are supposed to identify by yourself how many valence electrons magnesium has and how many valence electrons oxygen has. So start. You are supposed to only draw the outer electrons, outer shell, just like that. You're not supposed to draw inner electrons. So do not waste your time by drawing the inner shells. Okay, start. It's 2 comma 6. So hopefully you made magnesium oxide. Basically, I need to draw dot and cross diagram. How can we make it in an efficient manner, in a smart manner? You are supposed to look at the periodic table. You are supposed to look at the periodic table and then just see the group number of magnesium. So then you will say, then you will tell me that magnesium has two outer electrons because this is in group 2. And when you would be looking at the group number for oxygen, you will say that, sir, this is in group 6. So 1, 2, 3, 4, 5, 6. Okay, so you can just draw the electronic structure by looking at the group number, not the proton number. That's the shortest method to draw the dot and cross diagram. Okay, are you getting my point? Yes or no?
Yeah.
Okay, so oxygen needs two electrons. Oxygen needs two electrons. So magnesium would be giving its two electrons to this oxygen. Okay, I'm changing the color of electrons so that you can understand. So these are the two electrons that are from the magnesium. Okay, that are from the magnesium. When the magnesium has donated its two electrons to this oxygen, so afterwards, how many electrons of magnesium would left behind? So you will say 1, 2, 3, 4, 5, 6, 7, 8. After the removal of two electrons, it has plus 2 charge. After the removal of After the gaining of two electrons, it has a negative charge. As a result of this opposite charges, so they would be attracting with each other. Okay, they would be attracting with each other and they would be forming an ionic compound. In this way, the ionic compound is being formed. Hopefully you got all the points. Am I correct? Am I right?
Yeah.
Good. Okay, then afterwards, what are the properties of ionic compound? Can you tell me any three physical properties of ionic compounds? Any three physical properties?
So a physical property of an ionic compound is that it is very reactive because it has two both.
Oh,
It has full outer shells. Is that correct or no?
no. Basically, you are supposed to say that they are solid at room temperature. Okay,
Wait,
they
I'm
are
not.
solid at room temperature.
Do they have
Why
high,
they are solid at room temperature?
because they have
And they
high.
have high melting and boiling point. Exactly. Exactly, you're right. They have high melting point and boiling point, and they are soluble in water. They are soluble in water. Okay. They are soluble in water and they are good conductor of electricity. They
Yeah,
are good conductor of electricity in molten or aqueous state. In molten or aqueous state. In molten or aqueous state.
molten or aqueous state. What does aqueous mean?
Yes, when they dissolve in water, so they would become good conductor of electricity. But in fact, when they are in the solid state, so they are a bad conductor of electricity. Let me explain why this is so. And first of all, why they are solid at room temperature and pressure, and why they are having high melting point and boiling point. That is very important thing to know, that why they are solid. So remember, when we just studied atomic, like ionic compounds, then we came to know that all ionic compounds exist in this state, in this form. All ionic compounds exist in the form of lattice structure. This is called a lattice structure. What is lattice structure? What is lattice structure? When the ions are arranged in a particular manner, in a particular manner in 3D space, in three-dimensional structure, okay, in three-dimensional structure, okay,
Mm-hmm.
and this is basically a crystal lattice. This is just like a crystal, a regular pattern. Like how this is having a regular pattern. So I would say that, let's suppose this is sodium, this is chloride, this is sodium, this is chloride, this is sodium, this is chloride, this is sodium, and this is chloride. Ultimately, now you can see how they are arranged in a regular pattern. In a regular pattern. So you can say that uh, due to the presence of many cations and many anions, so the attraction is quite stronger. Due to the presence of a lot of cations and a lot of anions, the attraction is very stronger. When the attraction is stronger, what we have learned in the last chapters, like states of matter, like we have discussed, in the solid state the particles are tightly packed together, and there is very strong force of attraction between the particles. So this is the reason the particles cannot move when they are in solid state. Same goes with this ionic compound. So when they exist in the form of lattice structure, as you know that, yeah, like a lot of cations and anions are there in a lattice structure. Due to this, there would be very strong electrostatic force of attraction. Due to this, there would be very strong electrostatic force of attraction. Electrostatic force of attraction. So when there is very strong electrostatic force of attraction, so you can say that a lot of energy would be needed. A lot of energy would be needed to overcome the force of attraction. A lot of energy would be needed to overcome the force of attraction. So this is the reason you can say that they are solid at room temperature and pressure, and they have high melting and boiling point. Are you getting my point? Yes or no? Is that correct? Is that correct?
Yeah,
Should I
yeah,
go
yeah.
ahead? Okay,
Yes.
good. And then I'm saying that they are a good conductor of electricity in molten or aqueous state. Molten means that at high temperature you have converted this sodium chloride solid into the sodium chloride liquid. Like you have melted basically. When you melt any compound, so what does it mean? You are going to overcome the force of attraction. Now the particles are far away from each other, and hopefully you have learned previous classes that in the liquids the particles have intermolecular space that is greater than the solid. Like, I mean to say that the particles are far away from each other as compared to the solid state. So when the particles are freely like when the particles are far from each other, so they can easily move. When the particles can easily uh, move, so good conductor of electricity, good conductor of electricity. When the particles can move freely, so that I can say that they are a good conductor of electricity. What is electricity? It's the movement of charge, it's the movement of ion. When the ions are free to move, so you can say that this is a good conductor. When the ions are not free to move, so you cannot say that this is a good conductor. Okay, and in the solid state, why they are bad conductor of electricity in the solid state? Why they are bad conductor of electricity in the solid state? You can say that As you can see, the particles are tightly packed. They are strongly attracted
Hello?
to each other. They are strongly attracted to each move. They cannot move, having very strong attraction. When the particles cannot move, so you can say that they are a bad conductor of electricity in solid state. Okay? Yes. So that's the ionic compounds. And then